Let me just set up my live stream. All right, so welcome back to the Friday weekly Open Studio. Since I just done this stream, and that was mostly due to the holiday season, and then just some familial obligations, so to speak. So it was my sister's birthday. Just wanted to spend the day with her. On a Friday, I went out for dinner even in this crazy time. But yeah, essentially, I had to take 2 weeks off. Last week, I believe, last week was my sister's birthday. The week before that was Thanksgiving. So that's why I haven't really been able to stream lately. But the plan is to continue this week. I made a community post on my channel, so if you go and click through, you'll see the upcoming schedule for these streams. Next week, I believe we'll be streaming a little bit longer on both Friday and Saturday. I think I extended the time to 3 hours. So that should cover the past 2 weeks, and yeah, we should be able to make up some time there. So yeah, I'm trying to get back into the groove of things. So I guess we can just kind of start here, talking about what we did last time, which was ages ago at this point. So I just gotta remind myself what we did. So it looks like most of the prototype here is complete, but we're working on, which is this landing gear module. We're trying to build a cover, I believe, at the time. We're going to build some type of fairing structure it, and then we're gonna build more landing gear back here near the root of the thing, but not quite. It's a little bit beyond slats here. So it's going to be underneath this section. It's going to be mounted there, and it's going to come out like that. So hopefully it ends up well. But again, this is experiment, and it's been several weeks since I've worked with this, so I might actually make some mistakes, things like that. So that's expected with the design process when you're not involved for a long time. Kind of forget the detail, and you might do things differently and things like that. But point is, I am back again this week, and we're gonna try our best to complete the front landing gear, which is the first of its kind mechanism here. So if I remove the tape, it'll actually pop out, but I actually want to keep it on right now for the moment because we are actually working on the fairing that goes over, and we're gonna need some mechanism to actuate this little switch here. So it's to release the landing gear because this is the intention, and once you release it'll pop out. So actually, I think for the purposes of demonstrating how it works, remove this piece here, and it looks like it still works after time. Left it there for about 3 weeks, I think 2 or 3 weeks, and there's still a decent amount of tension left in these rubber bands. So these guys are really resilient and great for landing gear. Now I don't know, like, in a dynamic situation where your aircraft is cut down and it hits the ground really hard, I don't know if it's going to stay up, but at least I think for display purposes it's going to be okay. So you're going to have like 2 other landing gear here in the back supporting it, so I think it should be okay. But if you have like a hard landing, it might actually just coverage with short movement arm here to deploy this thing. So but in this video, or in this stream, more like we'll try and complete this fairing build over this, and the fairing has to have some sort of sliding door mechanism or something. It'll cover this landing gear and make it stay in place. So that's going to be a challenge. We are working on that, I believe. And then after that, we just have two landing gear to design, to integrate, and build a fairing cover for. It'll take a while. With the two upcoming streams that are going to be 3 hours long after today's stream, which is just a normal 2-hour stream, we'll be able to complete a lot of progress there. And I might actually even work on these two over the weekend if we get this first one done. Because mainly once you get one side done, it's quite repetitive, the other side. So maybe I'll just both and then results. I have a feeling it's probably going to be very close in configuration to this front landing gear here. So this pops out like that. I don't think it's going to be too different. I do have some concepts. I actually drew some concepts in my time away from streaming. So let me just show you guys. Sorry about that. I live right next to a highway, so it's really loud and noisy. But yeah, I did some sketches here in my little notebook just over the weekend, a couple days ago maybe. I don't have a pen, but I do have this drafting pencil here. So these are the concept sketches for some of the landing gear prototypes, right? So what we have right now kind of looks like this, right? We have a frame. We have this orange frame here that's anchored down onto the popsicle stick wood, base. And it's kind of hard to see. Let me zoom in a little bit. But yeah, this is like this view of it. Like if I flip this over, yeah, this is really hard to explain, but this is inverted compared to the drawing. So we have a base here, base frame. We have the little coil here that's built into the base frame. We have a serpentine kind of wire wrapped inside through this coil structure that allows this landing gear to actually rotate. So this is kind of how it is, right? And on this side of the structure, we have our big band, which adds the pretension element to this mechanism. And on this side, on the back side here, we have the actual landing gear itself. So these are not wheels, obviously. I don't plan on adding parts, but if you want to, I just don't feel the need to, because I mean it's gonna serve its function really as a sort of play stand, and it's not gonna be moving, so I'm just keeping it as a round kind of skid here. So this is kind of just how it works. I know the drawings aren't great because it's kind of hard to convey, thin wire geometry. So it's actually quite convoluted here. I did come up with this unique new design here. This one I actually built and tested out for the rear landing gear. I feel like this might be a little bit more compact. So the problem with the landing gear that I have right now, which is here, is that the fulcrum, the spinning pivot point thing, actually comes away from the fuselage a little bit, right? So there's a bit of a distance here. It slants up and then it curls into this tight coil. This new design, I'm thinking about just, putting that, coil onto the base of the fuselage as close as possible to the actual thing. And so what I'm gonna do is, it's still gonna act as a hinge. It's just now you have, so just sketch it out for you. You have your landing gear here, right, which looks like that. It's gonna be some type of triangular skid, right? And then so the pivot point is going to be here at the base of the fuselage, right? And you're essentially pulling So you have a little hole here for an elastic band, and pulling it back so that it swings open. That so this is like a pretension element here, right? So you're pulling it back, it's going to swing out like that. And then there's going to be some sort of mechanical stop. It's just going to be something in the way to block it from going all the way back, so it's going to set the angle of this landing gear, right? So that's the basic, very basic concept here. And you probably can't tell from this, yeah, it's really sketch, but I understand it. So that's all I really need in a concept design sketch. Just to envision types of things. If this worked well, I'm not sure because it's quite beefy, right? This is a first prototype, first of its kind mapping. I mean, it works. It's great. And, to prevent rework, I don't think, I could just leave it as is, but this isn't really packed and it kind of ruins the profile, right? So if you look at this sketch over here, just kind of a side view of the design. After adding the landing gear, we're going to have this bulky portion here, which other not be there. Look like that. Right? It'd be a lot slimmer, but with the landing gear, it's going to out a little bit. It's not like a huge deal. It's like aesthetically not the original intent, right? So, if I spend the effort, I guess the volume of the mechanism and then compact this down but we don't even know if the mechanism works yet, so I keep the node now. I hope I rework it, but if it's a really good, very clean solution, I actually might rework it. So the nice thing about this design, for this existing thing that we just made a couple weeks ago, is that the pretension element backwards through this lever kind of system. This is it's a class 1 lever where you pull on one side and you have your output on the other, right? Type 1 lever system. if you ever took a basic mechanics physics course. But the benefit of this is that it saves a lot of space, because in the front of your system, we want too much stuff here, because this would ruin the side profile, which is really sleek and nice. So to keep everything in this little space here, that's why we used this. You could say that that's a reason, but honestly, it's just how I designed it. So if we use the other concept mechanism that we have here with this element like that, so you've imagine this being flipped over, then the nose gear would extend, like the module would be extended this way, which is not what we want, because it would ruin the nose profile. I'd rather have it be closer to the center of the fuselage in the back than in the front. So that's why we went with this configuration. I guess on a subconscious level, that's kind of how I made my decision. Like, I didn't say it out loud, but I just kind of knew to go with this. But rear landing gear, we actually have a decent amount of space here. We mount it roughly here in this area at the wing root. We actually have a decent amount of space in the back, so we can actually use that extra space. I don't know how much we need exactly, but I would assume it's definitely enough for a pretension element going backwards instead of forwards. Another nice thing about this is that we can actually integrate it with so we're going to actually build the vertical stabilizers for this design on a boom. So it's going to be a twin boom, but open configuration. Let's see if I have a sketch here. Open configuration. That's That's an F16. So kind of like this, right? This is a concept sketch. I haven't built this prototype yet. Maybe in a future stream, but we have the vertical stabilizer mounted on a boom that extends beyond the wing. And the reason for that is to get fresh airflow and everything to make it more stable at high angles of attack. But the whole point here is that this structure that extends backwards, this anchor point can be actually somehow integrated into that boom, right? So that, doubles in function, keeps things pretty tight and streamlined, I guess. And when it folds up into the fuselage, there's gonna be a fairing there, and the fairing's gonna join up with the boom, and it's just gonna be really clean. So that's kind of the plan here, and the thinking behind this new concept mechanism, which is at its heart, it's really just I think this is like a second, this is like a second class system. So let me see quick. It's really all right. So I apologize for the technical difficulties. It's been really bad these couple of days. Let me know if the picture quality is better here in the live chat, because I think the stream is continuing. I just can't see my own stream, so I need your feedback. If that's okay. Much better. Okay, yeah. So right now I am actually streaming through LTE connection, not my local Wi-Fi connection. So that's new. It's gonna use a lot of data, but honestly, it's unlimited with Verizon. So I mean, if it works, then it works, right? So the Wi-Fi has been really bad here lately. So I mean, it's not only for these streams, but like for my personal use. So I apologize for that technical difficulties, but hopefully you guys can see it well enough. Hopefully I won't go over my data cap or something like that. Hopefully I don't throttle my speed. That would really suck. But anyways, yeah. So where was I? So yeah, that's kind of the thinking behind the landing gear mechanism, how we're going to proceed forward with it. Hopefully my phone doesn't overheat. Yeah, I'm actually streaming from a new phone. A couple weeks ago I was streaming from my iPhone 10. Now I'm actually using the new 12 Pro Max. If you can see the see the reflection in the glass here, it's the 3-camera system with the LiDAR. So I'm testing out new technology too. Some of you might have seen the test stream, which I actually made private on my channel, so you can't see it anymore. But I did a test stream with the Logitech Stream Cam, and it was absolutely terrible. Like, there was something about the Windows driver in that thing that just made it so laggy, and the noise made me sound like some sort of robot or something. So it wasn't really smooth. I would have used that camera as my main streaming camera, but it just doesn't work that well. So I am sticking with Apple's iPhones here, and I've never really had a problem there. They have the latest modems and drivers, and there's really no issue here. It's like, yeah, the stream cam is horrible. Yeah, I kind of realized that after I got it. It's really not that great, but I got it because I wanted to have like a video camera for Zoom calls and things like that, but it's not really great for content creation. So even though they market it as that. But anyways, that's besides the point. Let's just get working here on this prototype. If you're new around here, the point of these streams is really to create a studio environment. So you should be working on your projects while, you have this on in the background, or you could just leave this on like a podcast in the background and just like listen in to me commentating on my own process here. But yeah, it'll be you'll get more out of it if you definitely work on your own projects at the same time. I feel like it's kind of a creative studio environment. But anyways, we're gonna get started here. We're gonna go ahead and continue with this fairing design. So again, the first step here is to really create some type of enclosure that's really tight and aerodynamic. I mean, it's not necessarily going to be aerodynamic in any sort of refined sense, but some type of thing to cover this up so that it doesn't look like a visual distraction here. If it's streamlined, if it looks nice, it'll usually fly nice too. So we were working on this last time. This is just a white printer paper template, I think. And this actually, it's okay. It's a little bit short on one side, but I just need a symmetric piece on this other side here. And maybe make this a little bit longer. I'm not sure. But we need to test out this template and then eventually transfer it to a actual cardstock piece of material. All right, so this is actually quite difficult to disassemble. All right, there we go. So this is kind of what the geometry looks like when it's unfolded. You have like a little triangular piece here that defines the side profile, and you have this front piece that folds in to form that front edge here. This is like not the most aerodynamic shape, but it's the easiest shape that we can actually feasibly make. So, shoot, I need to get my paper and cardstock and materials real quick, so let me just grab those. I'll be right back. All right. Yeah, you have some planes here, the F-16, the Rapid Prototype. I still need to make videos for these. I am so sorry. I've been like slacking on this. So, but it is what it is. Life gets in the way, you get busy, things happen. So, just move this to the side here real quick. I hope my phone doesn't overheat. Yeah, the larger size might help. That's the nice thing about a big phone. It doesn't overheat as quick. It has more surface area to let off the heat. So, anyways, yeah, we did some concept sketches here with how the fairing is going to look. And we have an actual piece of paper here that we cut into to prototype with. Oh yeah, look at these sketches. Yeah, this is kind of how the mechanism works, but it's very rough. You probably can't really tell what's happening, but it is what it is. All right, so I'm gonna remove this little tab of tape. I think this geometry does work. You just need to make it a little bit longer this way, and we need to make it symmetric on the other side. Those are the only two conditions here that we need to model. Make sure we capture that. So let's move that up. Ruler, X-Acto knife, tweezers, scissor. All right, so we got all our tools in place. Oh god, I hope cellular connection is stable enough and I don't throttle it, because if I do, that would be tragic, because my Wi-Fi absolutely sucks right now. So if If you're in the Northeast, you're limited to only Comcast and Cox. And at the apartment where I'm at, Cox is the only provider, so they literally have a monopoly, which, as you know, is not great for the consumer because they have no incentive to make sure their service is actually decent. So that's just me complaining a little bit, but don't mind that. Shift this back a little bit here. I think this should be enough to extend it to this fuselage base here to cover a little bit of this area. But if it's too much, I think we can actually trim back. No big deal. This is still a template. This isn't the final piece yet. So I can just zoom in a little bit closer so you guys can see better. Frame it a little better. All right, I'm gonna rotate this a little bit. There we go. And I'll mark that right there. And the nice thing about this is that we don't even need the other side. We can just flip it over, line up the edges, and trace out the other edge here. So that's just a clever use of symmetry to save time. Okay, so that didn't turn out too well. Let me see here. Yeah, it looks like we're gonna need some help, some assistance here. The straight edge. Okay. I'm just gonna mark out some lines. It's really okay. So I know symmetry is a thing. It does help, but you do need this. I don't know what I'm talking about. I'm just mumbling to myself. It's the end of the week. It's been a long week, dude. It's crazy. Anyways, at the end of the year, that's when people start leaving the company, you know, like as in for vacation. And that's when the IT people start upgrading everything. And everything just breaks and stops working. It's just a nightmare trying to pump out deliverables when the tools that you work with don't even work. And that's the thing. Tools, they should work. You shouldn't be debugging them because honestly, that's not my job. That's the IT people's jobs. Make sure the tools that we use work. Quite frankly, they're not doing their jobs right. So I feel like every big company is like that though. Everybody is just like complaining about IT all the time. It's like, God damn it, why does my Outlook email not work? Things like that. But anyways. Whew. All right, so now we can cut this out and I think we can go a little bit more here just to be sure. And actually on this piece, we can have some tabs here. We're gonna draw a little bit here. I realize I'm eyeballing this, but I think this geometry should be decent, should be workable. And this back end just melds into the fuselage. So this is going to be a tab. All right. And then this tab will go under this tab once it folds into place so that we have an area to tape on. So I'll show you how to work that, but if this ends up working, this will be a great template. All right, let me just zoom out a little bit. Move the prototype over here to the left side. It's not in the way. I am right-handed, so I need the right side to be clear. Okay. All right. Okay, that looks good. Oh, I'm gonna cut this edge and then this edge. So that's the thing with these parts; they are highly precise. Right? So you can do with simpler shapes and still get away with it, but that's the thing that I learned working at an engine company, is that complexity is not necessarily a bad thing, right? Because if you think about it, if you have one part that fails like 1 in 100 times, right? That's not great. And to improve upon the chances of a system failure, if you double the parts there, then you have 1 in 100 times 1 in 100, which gives you 1 in 10,000, right? So by that principle, I mean, these numbers are different. They're not actually 1 in 100. By the same principle, if we engineer a part to very small chances of failure, and then we double that, we effectively reduce the chance of a system failure by a ton. So essentially what I'm trying to say is complexity is not a bad thing. It's, like with the modern design trends and everything is becoming more and more minimal, which, it makes sense in a consumer setting, right? But when you're talking about flight and, you're thinking about people's lives that are at stake, right? You don't want simplicity. You actually want a little bit of complexity, so you make sure that the part won't fail and end up killing people. So complexity enables higher degree of fidelity, I feel like, and that's the thing that I learned most here. The more complex your parts, the more you can get out of them, right? Because nature isn't just clear cut, single geometry, like, right angles and things like that. Nature likes to create things that are organic in form, right? Just look at living things, for example. We are essentially machines, just biological machines. We're not made of metal, obviously, but we have mechanisms and things within us. They're not necessarily mechanical mechanisms, right? They're biological pathways, and these molecules, they fit together a certain way. They're kind of like little machines on their own, but it's not a machine in the man-made sense. But life gets complicated, and look at how much we can do, right? You can't do that with a simple single-celled organism. Can't make jet engines if you're a single-celled organism. Anyways, I'm just like going off on a rant here, so sorry to distract people. But yeah, let me see. There's chat here. Yep, no new chats. All right, yeah, let me know if there are quality issues with the stream. Again, they might throttle my cellular data, or my phone might overheat, because I am using cellular to live stream, which is not advisable in the days when data was not unlimited. But now that I have Verizon and it is unlimited, then it really doesn't matter too much, I guess. They might change the speed, which sucks, but you gotta do what you gotta do, So Unfortunately, there's no 5G here, so I can't stream 4K, which would eat up the data real fast, but still interesting to think about the possibility of doing that. So this tab is going to be interesting. I'm going to crease this. So, oh shoot, all right, so you're just going to do that, slide it underneath, and give it a fold. I'm going to fold it onto the other side here in a bit, like so. And then on this side, I'm going to do the same thing, line it up, give it a fold, just a little crease, doesn't have to be a, alright. Alright, and then that's pretty much it. And then these two tabs, once we fold this in, right, kind of see how this fits together. These two tabs will support this centerpiece. It'll act as an anchor on which to tape this middle panel here down. And then this middle panel also has a little bit extra here just to create a smooth edge, right, with the fuselage. So we're gonna have to tape that in place, but it'll create a seamless edge. Well, there still is a seam, it's just not at the base of the thing anymore. And then the other side is the same, and this should be our final fairing piece. So I'm gonna test this out real quick using a little tab of tape. I think we're only going to assemble one side because we don't want to over secure this thing. It is just a prototype after all. We still need the plan form. The purpose of this piece is not to actually be the final piece. It's to serve as a step in between to find the proper shape so that we can make the final piece in cardstock. Okay, so I don't feel like there's a need to really secure this side, but let me try this out. Let's see. All right, so this seems to be a tight fit, which is good in a sense, but it's a little bit, oh wait, actually I know the problem. It's because we didn't remove the tape. This tape likes to expand out a little bit. Right, it's a slant here, so it actually exceeds the footprint of this fairing. So it widens it at the back, so we gotta take it off. So we don't have that issue. This is like troubleshooting. So you solve problems step by step. Oh boy, all right, yeah, it's really fighting me, this mechanism. But look at that. Look at that. Kind of fits, kind of works. Right, some type of fairing like that. It's not the smoothest looking thing, unfortunately, but it is gonna work, so that's the plus side. I want to see, okay, I feel like we do have to secure this side to really get a feel for the assembled state. Just grab a little piece here. You don't even have to tape on the inside, but honestly, it's probably easier to keep it all inside. Of course, on the final thing, we will tape over the outside to make it more aerodynamic. But this looks like a decent fairing. I didn't intend for this little curve, but it does want to pop out a little bit. I feel like that's due to the fact that I didn't really crease it too hard in the back. But you can definitely adjust that. Okay, let's just see how this fits. Let's fold that down. Fold that in. Make sure the mechanism is tight. I don't know, I think it's decent. Might not be the best thing in the world, but we can definitely smooth out some of this geometry with, oh, sorry, you guys can't see. We can smooth out some of this geometry with additional side panels here, right, to make it really smooth, but that has to come after this fairing, right? So essentially we can add additional panel pieces here to help smooth out the transition, but the base fairing itself needs to be quite resilient and ready to handle this. And then the hinged door, I believe, is going to have to, well, this is kind of where it has to have the hinge. I have to cut a little door in this thing as well. So this is quite complex. This is very complex stuff right here. It's definitely overkill for a paper airplane, but we do what we do because we want to do it, right? This is like an art in and of itself, creating these sculptures that look nice and actually fly. So this is looking good, actually. I really like how this adds like a little bit of character to the front, and it kind of juts out, but then it's like, I don't know, it gives it a muscly kind of look. It's kind of like conformal fuel tanks or something, you know, like on the block F-16, you know, with the ones with the external fuel tanks. I don't know. Looks a little bit goofy, but it's not too bad, all things considered. Probably gonna need a little handle here too, anyways, for grip. Now the question is, if we do that here, what's it gonna look like? Oh, that's gonna look interesting. More fairings. Give this plane all the fairings. Dang, look at that. Imagine that on top. Just like that. It kind of looks like an engine nacelle or something. Imagine like the geometry being custom tailored to this little edge here, right? That would be pretty neat. I don't know if I want to mount the boom on top. I think I'm gonna put it on the bottom because that makes it a better integration, I feel like. But that's my opinion. I don't know. What do you guys think? Let's see. Are there any comments here? New comments? No, not this one. Hi, hello. I see you. I see your comment. Benjamin Rogers says, will this cover slide as one unit or have a door to access the landing gear mechanism? So yeah, the idea that I have right now is some type of cutout on this fairing, right? Oh, I don't know why I'm using a scissor as a pointer. Let's see. All right, so some type of door, right? So this is going to be cut out like a C shape, like that, right? And or you know, it could be an H-shaped cut, and you know, with an H-shaped cut, that would be nice because you don't have like this huge piece coming down with it. So that's the benefit of that. But also, we could just straight up cut this whole thing out like a rectangle and let the landing gear slide down, and then have a sliding piece that, you know, acts kind of like a rail here. So I don't actually know. That's the fun bit here. We're trying to figure out how to make this mechanism work. I am not really sure about this, but we could even, you know, mount the thing quite far back and have it slide on a linear kind of rail of some sort. That ways we can just grab it here and then slide it back, and then the whole thing will just pop out. But I feel like to do that, we need to really progress a little bit more. We need to actually build this in the final material to understand how the mechanics of it will behave. So right now we have the geometry down, base fairing geometry. Yeah, it doesn't look too bad. Oh, yeah. It's just popping up a little bit. But this is kind of what we have now. Right, and then yeah, some sort of sliding bit here that reaches all the way forward and releases the mechanism. So I don't think the sliding piece will be built on the fairing. It's going to be built somewhere in the back, reaching forward, maybe. Something like that. Yeah. It's quite a complex piece of geometry here. I've never actually designed a moving piece that deploys like this. It's always been like control surfaces, which are already built in and aerodynamic. I've never built something like a landing gear before, so this is my first time doing this. Yeah, we're definitely going to have to adjust the side profile a little bit. We definitely need a handle of some sort in the back, so I don't know. Maybe that can serve as kind of the lock, like a sliding handle lock or something like that. But I am not really sure. I have to think about it a little bit. But for now, we should make a cardstock version of this so that we get one step closer to that end goal. I feel like for these side panels, we could actually attempt oh shoot, yeah, this is really stubborn. This thing is alright. Yeah, we could try adding panels here, but I don't know. Because right now there's a tiny little gap. See that? So if we add an intentional piece here, that should help with the attachment point. I'm not really sure if I should do that. I feel like that would make it easier to attach, right? So I think maybe, yeah, okay, let's try that out. Let's try that idea out. So I'm gonna mark this point, and we want a tab that comes out like that, right? That way as we tape it here, and it'll secure this edge down. Nice. I don't know about the back, maybe the same here. So add panels to this geometry here and this geometry here in the back. Okay, so we have some changes to make, and I think in this final iteration here of prototyping, we are going to make those changes and incorporate them directly into the cardstock final piece. That ways we save ourselves a little bit of time. We are already an hour into the stream. Damn, time flies, man, when you're working on these things. Let's see if there are any comments here. Nope. All right. Just gotta remember to check every now and then. Okay, so this is kind of what we need, and alright, so I'm gonna trace that, trace down here. Okay. Yeah, sorry you guys can't really see that. Let's move that closer. Okay. Do that. Get a slant to there. Okay, trace that edge down. Okay, and then this point right here, I'm just gonna transfer it over to this side. And I don't know, for this, I feel like just a rectangle might suffice. Yeah. All right. So let's see. This is 0.8, 0.8. 0.8. And 0.8. Excellent. All right, did I mark those points? Let's see. Yeah, I did. All right. And we should be all set to go. So just now it's a matter of connecting the dots that we drew marked out for these parts. And right. Okay. Something like that. And just fold this, or not fold it, but draw the fold line all the way down. And right, we need another tab on the back here. That's gonna be fun. Alright, we're just gonna eyeball this. I mean, as in like the initial alignment here. 0.8. Right. Then 0.8. I think this is perpendicular. 0.8 like that. Connect the dots. Doesn't look really good, but it's a tab. It's not really functional other than serving as an anchor point. Go out to 0.8 there, 0.8 cm. So that's the thing with me, is that I like to switch between units, but I'm sure some of you already know that. Alright, yeah, that looks decent. Now I just gotta cut this super complicated part out. This is where like a CNC laser cutter or something like that, Cricut, whatever, where that would be useful. It's not for the simple shapes, but for these really hard shapes, it saves a lot of time. And it's very, very precise. Alright, so Benjamin Rogers says, before you attach the cover over the landing gear, will you mark out the places for the door? I feel like that would be the smart move. That would be the smart thing to do. I don't know if I'm going to be smart. I just want to make this door first, this cover. The door, honestly, the door is like, it's going to be either a hole or a slit of some sort, right? And the cover itself is going to slide over that opening. So I think we're going to have to worry about the cover. I mean, the cover in the sense that, like, the thing that slides over to prevent it from popping out. We're going to have to consider how to design that later. I'm not very good at mechanical design. If you couldn't tell already, this is not my major. I should have majored in mechanical engineering, but I didn't. I have a background in aerospace, so aerodynamics are more my thing. So these doors and hinges and things like that, I'm actually learning for the first time on my own, in addition to, you know, whatever YouTube videos that I watch. There are lots of good videos out there on many different mechanisms. It's kind of inspiring looking at them, but also it's like really hard to manufacture and translate to these materials that we are working with. These mechanisms in general, they're very intricate and difficult to get right because the lengths have to be exact. And, you know, we're hand making these things, so it's actually really difficult to do that. This is why handcrafted mechanical wristwatches are so expensive, because it takes a very long time to make something that move so precisely. You know, it's not only the engineering and theory behind it, it's the manufacturing time and energy and effort and skill behind it. So we'll figure it out once we get there, but we need some sort of cover first. Right? That's my short answer to your question. Okay, so that makes our life a little bit easier. Now we can cut this without having to hold that giant sheet of paper. This type of paper is just really stiff, so it's kind of hard to work with sometimes, but stiffness is what gives it material properties that are desirable for structural components. I think someone did the math somewhere on the internet, and I read that, paper airplanes are the equivalent of aluminum, right? Like if you use regular printer paper, the end result is kind of aluminum on real life aircraft. But if you use cardstock like this, it's more like a steel, like a lightweight sheet steel. So it's not as efficient weight-wise, but it's very freaking strong, which is what we need, because if we're building a glider that, looks great and has moving parts and, flies great, we want it to last a long time, right? We don't want it to just crash and, one-time deal, it's done. We want it to have a longer life, so you just need to make it more durable. That's why we're going with these material selections. And for the most part, these models are going to stay indoors. You're not going to be flying most of the time, right? So they're mostly display models in a sense, too. So anyways, sorry for that tangent there. All right, so now that we have this fairing piece cut out, we are going to fold this. We're going to start with the outside folds just to make things a little bit easier on ourselves, because if we fold this middle part, then we have this giant kink here, and it's going to be hard to fold this outer bit. But if we fold the outer bit first, we won't have difficulty folding the inner side. All right, let's just crease it like that. All right. Just crease it like that. So these are actually going to fold the opposite way, because this is going to be on the outside. Right, so it's going to be, this is how the fairing is going to be attached. Now we're just folding the rest of it. Makes sense to me. All right, actually, we gotta do the other side first here. All right, here we go. Just gotta lift this up and there we go. There we go. And we're gonna fold it, reverse this fold, but it doesn't matter too much at this point. like that, and then like that. All right, that's good. And then for these tabs, for the rest of them, they're gonna be just regular folds, I guess. So the difficult bit working with cardstock is that material is quite stiff. I think I've mentioned that before, just 5 minutes ago. But crease that. I'm gonna do the same thing on this side. Crease that. This one is going to be a deeper crease because it's one of the sides of the fairing. There we go. There we go. Just a little fairing piece like that. And these two are going to pop out. These two are going to pop out. And then these two tabs are going to go in. And it's going to be great. It's going to be great. Like that. So look at that. These tabs just fit together. All right. So quite a complicated bit of geometry here, but hopefully it pays off. We did mark a cutout here, I guess like a hinge point on this piece right here. So I'll translate it here, but it's gonna be like right about here-ish. I don't know what I'm gonna do with that yet. So I think I'm gonna just assemble this and then see about that door, about the hole in the door, in this fairing cover thing. Wow, I am so out of it today. I am so sorry. Okay. Let's do this. Let's do this. We got this. Got this. Just get some tape. Get some tape. All right. Hyping ourselves up. We got this. Positive energy. Right. Anyways, apologies for that. It's just a little bit too excited there. Why does this gotta be so difficult? Oh my goodness. I think the problem is this side not folded. Okay. Well. Alright, just gotta kind of wrestle it into the place that you need it to be. You're still gonna need tape on the outside, but this tab on the inside is gonna help us secure it in place first. And then this bottom, okay, yeah, there's a little bit of wrinkling in the tape. No big deal. I'm just gonna trim this. Oh yeah, last time I broke the X-Acto knife a little bit, so I might have to change the blade soon. Like the tip is not super sharp anymore. Anyways. Just gotta fold that underneath. Honestly, this would be so much easier if we could just like soak this cardstock material with water, just like compress it in a mold, and then have it dry it up, like baked to perfection, so that it's hard in that position. And then I don't know, I'll have to like experiment with that. The problem with that is you need 3D printed tools and molds and things like that. But it's the next evolution in paper aircraft design, I guess. Just very smooth 3D shapes. Anyways, sorry for the distraction there. Just gonna take a little bit more here. Did I already take a piece? Yeah, okay, sure. I accidentally put this little triangular scrap piece from earlier onto this piece, but no matter. I fixed it. Problem solved. Alright, now I'm just gonna mount this piece of tape on here. We're gonna fold it in and shit. Alright, that's not enough surface area. Alright. So I don't think this is ready. This is not good enough piece of tape. Or maybe we just put it on wrong. Maybe. Okay, yeah, that looks decent. It doesn't look too bad. I do need to smooth out the sides, so let's do that real quick. All right, and then we're just gonna trim the excess here, so we don't have to deal with that. A triangular scrap piece. All right. Okay. Yeah, this entire stream is just gonna be dedicated to this one fairing cover. That's amazing. Wow. Okay. Okay, just gonna trim this a little bit off. I see. So that's how it's gonna be, huh? All right, Doesn't look too bad. Doesn't look too bad at all. All right, I'm just gonna fold these 4 tabs apart. This front tab up. We'll increase the steepness of this. Okay, let's see how it fits. This is a moment of truth. Does it work? Does it? Kinda. Yes. It's a lot stiffer than the prototype piece, so it feels a lot better. Look at that. We built ourselves a fairing. Doesn't look half bad either. I feel like the gray really helps blend it in more. It doesn't look bad at all. I really like it. It's a part of the design, right? Unfortunately, it's gonna have to jut out like that, but you know, I think I can kind of lean into it a little bit. It's growing on me. It's kind of like the camera system on the iPhone 11 and 12s, you know, the 3 camera array. Kind of looks ugly at first. I actually really hated it, but then now it's like, oh, okay, that's iconic, you know? That's quite nice. I feel like this is one of those features that's going to be like, why is there such a massive thing jutting out the bottom of this airplane? It's like, oh, okay, well, it's the landing gear system, right? This looks kind of nice, I'm not gonna lie. I'm just like hyping myself up, I feel like. But, you know, you gotta do what you gotta do to keep yourself inspired. And I like to inspire myself with my own work, so that might sound a little bit arrogant, but I mean it in the most sincere way possible. Like, if your own work doesn't make you excited, then, you know, it's hard to keep yourself going, right? I feel like early on in my hobby, when I got started with this, it was a lot of self-inspiration. I was like, cool, I can do this. I can build on top of that. I can improve here, I can improve there. And then more recently, it's been more marginal improvements. That's why, you know, kind of, I guess the rate of output kind of slows down, because you spend more time on these projects to make them better. So the progress is still there, but it's just a lot slower now. So this looks decent, actually. This looks really good. All right, now let's see. Okay, so the hinge is gonna be right about there. Okay, yeah, actually, let's do one more thing. Let's put this back on and mark out where this thing needs to sit properly to get a good installation. Because once we have that information, then we can start planning about the mechanical pieces of this landing gear door fairing thing. Alright, so it's gonna curve a little bit like that. I'm gonna have this little rectangular piece here. I feel like that's enough to give us an idea, but I also just, I don't know. I feel compelled to draw lines everywhere so that we have more information about how it fits together. I'm like kind of mumbling to myself. I'm so sorry. All right. This is how the footprint of the thing is gonna look, right? The hinge is located relative to this little outline. It's probably right about there. I feel like the simplest thing to do for now is just to cut a slit down the middle, because that will probably be enough to allow this thing to pop out. And yeah, let's see how that works, right? So it goes all the way down to here, I believe. Yeah, all the way down to about right here. Gotta go a little bit extra to give it margin. And then we're just gonna slice this down the middle. But we're not gonna do it on this side. We're gonna... Shit, alright. Let's see. We're gonna mark it on the inside here. And then we're gonna slice down the middle from the inside out, not from the outside in. Just because it's easier. It's probably the cleaner solution too. I do need to switch out the blade. I don't know where I keep my X-Acto blades. This is gonna be difficult. Actually, let me just test out if this is even possible. Okay. Looks like we sliced through pretty clean. I feel like this hard corner gives it a sharper edge of some sort, you know? But anyways, first step is to mark out just exactly how wide this thing is. I think it's 1 cm. Yeah, it's 1 cm perfectly. So you need half a centimeter here. And then this is gonna be so hard. All right. Yeah, we did not plan this out, right? All right. New idea. Do this. 1 centimeter, from 1 centimeter to 2 centimeters here. That's the length that we need. And now we just fold it, kind of. So that it fits inside. And then half a centimeter on this piece that we can kind of lie flat. Half a centimeter. All right. This is innovation right here. Damn it. All right. It's a little bit frustrating, but for the most part, I think it works. Just got a trim right here. Okay, we marked the midpoint. That's all we need. Just need 1 point. All right, we got 1 point right here. I'm just gonna make it go all the way down here. That's it. That's the cut line right there. It's gonna be real freaking difficult to cut a straight line without being able to lie this flat. But we're gonna try our best. That's the attitude, right? All right. So this is gonna be kind of tricky. Freehanding this, because we can't fit a ruler in here. I don't want to try cramming one in. Just kind of have to really carefully cut open this. You can freehand things. It's not a guaranteed failure. It's just oftentimes it's easier to use actual straight edges to help. So that first cut was kind of like a score cut in a way. So now the knife knows where to go, and it's going to help us cut this a little bit better. Okay, just when I said that, it starts to... Alright, there we go. That's a lot better. Alright, let's see how this works. All right. It doesn't look too good on the outside, but that doesn't matter because we're going to add a cover. Alright, yeah, this is getting a little stressful, because if this doesn't work, I don't know. It doesn't work. Maybe. I could pop the landing gear out and see how it works here. Ooh, I think it needs to be a little bit longer. This is the point. Oh yeah, we actually marked out where we need to cut. It's okay. This is a little short. So let's slice the rest here. If the cut is too large, it won't really matter too much. It'll just make the piece a little bit weaker, but this is a prototype, so I don't expect full fidelity out of this piece, but let's see how that fits. All right. Boop. Hello, this is my leg. And then just pop that down. I don't know, this is looking kind of interesting. Yeah? Maybe we don't even need a cover. Oh, it kind of shifts a little bit right now without being taped down. That's interesting. I feel like this would benefit from an actual slot instead of a slit here, because the material is just interfering too much with the movement of the landing gear. Right? Like, so if we do that, there's a ton of friction here, but I think it does fit around this entire sub-assembly really nicely. It's just a little bit complex, I guess. I mean, this, what am I kidding? This whole thing is complex. All right. So something like that. Once we tape that down in place, I'm just seeing how this mechanical piece is going to behave. It's going to jam, right? So we do need to cut out a little slot, it appears. All right, should just yank that out. All right, so see, it didn't matter, right? Because I mean, I guess we found out what did not work, and now we have to make adjustments. Yay, so fun. All right, just gonna zoom in so you guys can see. Let me know if there are any qualities with the stream, quality issues. So I am my own tech support at this point. So we're gonna slice that edge right there. And oh, that's gonna be a no from me, fam. Right, this side. We are going to slice down here. And hopefully this little gap should be enough to allow for the landing gear to slide out without any issue. Again, this is going to be a precision cut freehand. First pass, it's going to be a score cut. This isn't precise or perfect by any means, but it's a slot that will be covered up by some sort of cover. Okay. Looks good. I just need to slice the rest of this off. I really should have done this before folding the whole thing shut. Now I'm paying the price. Yeah, scissors are too big to go in there and chop stuff up. Yay, okay, I got one side off. Oh, right there, okay. There we go. It's a very thin opening. I just need to do the other side. Shit, alright. There we go. Alright, it's looking good. It's looking good. Just pop that out there. Okay, now we have a window of sorts. Doesn't look too great, but we're gonna cover it up. Yeah, that looks alright. Doesn't look half bad. I just need to figure out a way to add some sort of thing to this thing to lock it in place. Alright. Anyways, I think we can start attaching this fairing. Honestly. This looks decent. There's no major issue with this. I think, it'll just pop out. We just need something to cover it in place. And then just slide the cover back. And then it'll come out. And then we can slide the cover back to cover this little piece, little gap here. But overall, it works. This is the first time I've made a landing gear system. That's amazing. Everything works. All right, yeah, so the outlines that we drew aren't gonna work anymore, so I'm going to erase them. They were good for prototyping purposes, but they're not relevant now because the fit is different. So I'm just gonna erase that. Okay. If we finish this today, I'm gonna be so happy. One piece at a time. That's the philosophy. This is the way. If you watch that show, you'll know what I mean. This is the way. Let's increase the intensity of this fold right here, just to help the front out a little bit. I think cutting a slot in the middle of this thing changes the way it flexes and just overall the geometry, how it behaves, which is a little bit unfortunate, but to be expected, right? If this were solid, the stresses would be distributed differently, and the shape wouldn't deform a certain way. So that actually makes a lot of sense. Okay, this is good. How am I gonna secure this? I feel like what I need right now is a massive tab of tape on this side. I'm not sure if this is actually necessary, but I'm gonna do the same on the other side. Oh man, here we go. Okay, looks all right. It's a little bit too much extra stuff there, but let's see how it works. Ooh. Is that good? Or nah? Okay, so it's not perfect, but I feel like it's as good as we can get it to be for the most part. Yep. I don't know, just gotta zoom out and take a look. From the front, it looks great. From the side, it looks, well, it looks like what it looks like. From the back, it's a little bit crooked. But great for the most part, yeah. All right. I think that'll fix it. Now it's just a matter of securing the panels to the side here, which I will do right now. Okay, so this is a little bit challenging because it's cut it's not precise enough so that it avoids the canard here. So I'm just gonna make some delicate cuts. In between here. Hopefully I didn't cut any other important surfaces. That should be okay on that side. On this side, okay, that didn't work. Alright, I'm gonna need to adjust this a little bit. There we go. Adjust the canards so that I can slice right next to them. Clean this tape up so it doesn't jam up the mechanism. Pull back. Push forward. Make sure nothing jams here. Okay, well, it's a little bit there, but that's to be expected. Okay, looks good. Got the sides here done. Just gotta get the forward nose here with a half piece of tape. Use this piece as a cross piece of tape here. This is really to compress the other piece of tape down so that it doesn't lift off. We're gonna have to add another panel here to smooth things out a lot, but for the most part, this is looking good. So this cover. Just hold that in place. See what we can do here. isn't a perfect fit, but still try and get it to be as nice as we can make it. Looks okay, all things considered. I think we can build another structure here that, slides something here to cover this up. And if we can get that to work, then this landing gear will be kind of done. Right, look at that. Slides in, slides out. We need like a little bit more space. It's gonna be really hard to make these changes locally. Yep. Let's see what we can do about this side here. Yeah, next time I'll have to design the landing gear better into the fuselage. This time it's just, oh well. But look at that. Folds in, folds out, folds in, folds out. Not bad. It's just now we need something to really seal it up. On an actual airplane, this would be controlled by doors. You could just add 2 motors here that cover the doors. But here, we don't have that luxury. We're operating on a totally different scale, so. Yep. So let's see what we can do about that. Just cleaning up some of the edges here. No big deal. Okay, so let's examine this a little bit further here. Again, this is the design process. So you come up with ideas, you test them out. If they don't work, then you iterate. This looks okay, but my main concern is we just need something to cover this up so that it's a little bit more sightly, right? We need something with structural rigidity and is sleek enough to fit over this. I could use popsicle stick. I really don't like the idea of having something so thick on the bottom here. So by that logic, if we constrain it by material, then paper is really the only way to go. Right? Huh. All right. Let's see. All right, what can we do? We need like some sort of sliding cover, but the problem with the sliding cover is we need to be able to get it to stay on track here, which is going to be really hard to do. Let's just prototype something here, right? So we need a little chunk of paper. Okay, let's just cut this off right here. Let's see how this works. Doesn't even have to be great. Just fold this piece of paper, right? Okay, so something like that, something like that. I want this to slide, right? Like that. Be stiff enough so that it doesn't bend. And then once it gets here, landing gear comes out, landing gear retracted, and you slide this all the way to the front, right? But that sliding movement is also constrained by the fact that this back here slants up, so you can't really do that. What about a folding door this way? Because if that's the case, it's just not going to be as elegant of a solution. We're just going to have to install some panel here that'll fit in. Yeah, that's not the best solution, but I think that'll work the best. Because really, we need this thing to survive actual flights, right? So if we have a sliding cover here, it's gonna be too intricate of a mechanism. If we just slide it down and then just attach a piece like that on top. So maybe like a separate flight mode or something like that. You can make a sliding cover that runs on a track with the part wrapped around the sides being covered, and covered the way to anchor it is through distressed strips of paper that allow for the sliding motion. Sliding cover that runs on a track with the part wrapped around the sides being covered. Way to anchor it is through distressed strips of paper that allow for the sliding motion. I think you'll have to show me through like an image or a sketch or something. It's kind of hard to convey these ideas through text. It's easier to see pictures. Let's see. Yeah, this is an interesting problem. Just thinking about how to go about this thing. I'm still pondering about this problem. I'm not sure exactly how to solve it. A piece that folds down like that. This is really a packaging problem. How do we package this nicely? It's a sliding piece. It has to have a very smooth movement to make a good result. I'm not really sure. Haven't thought this far ahead. Okay, so I'm thinking about the side profile right now, because this looks weird, and if we want to solve it, I feel like the best way would be to have like some type of horizontal bit here that tapers off, right? So if that's the case, then we can extend this geometry out this way on a straight line, like that. That'll give us something to grip when we throw, right? Okay, so sorry, you guys can't really see, but if you do that, I can grip onto this, and this entire structure might be able to house some sort of sliding bit It just gives us a little bit more room for design. But yeah, this is a very interesting problem. I don't think I've ever had to think about this until now. It's a very, very interesting problem. But really, all we need is... Oh no, 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 no. We need to cover this whole thing, because if it comes out like that, we don't want this to look weird. Right? We want something to be able to slide back and cover that. So this is how it fits right now. Could have like a triangular piece to make it structurally sound. Right, with little material near the front, a lot of material near the back. But then this, see, the problem with that is once you slide back far enough, this starts to bend, and it's not ideal. What's that going to slide on also? That's the other question. I think you could have like a really long rectangle here with like a piece wrapped around here. And what's going to keep it tight, right? These are all questions that need to be answered. This is really difficult. This is not a very easy thing to do. Yeah, this is a interesting problem to tackle. But otherwise, I mean, this works great. It's just how are we gonna keep the legs in, right? So we could have like a distinct flight mode or a distinct display mode with the landing gear down. Now, I'm not sure if I can solve that problem today, but it's something to think about. We're almost there. We just need to fix up the side profile a little bit with a potential another fairing here. Just a flat bottom of some sort. And yeah, it's just this how are we gonna keep it in? What the fuck? Like, I don't know what I'm gonna do. I just have like a tension fit piece, but even that's gonna be hard, because how are you gonna... You need the material property of like some metal component to really make this work. And even then, it's gonna be held on by friction. It's not gonna be held on by reliable, good engineering judgment, you know. But yeah, this is a very interesting new problem that I'll have to figure out probably this weekend. I'm probably gonna tinker around a little bit. I may or may not do a stream, an additional stream this weekend, but if I do, I'll be sure to let you guys know. And well, I'll just stream at the usual time tomorrow if I do end up streaming. But this is looking good. This is like really sleek looking. It's just a little bit weird because it wasn't really designed for this side profile, this landing gear bit. So we're gonna have to build some fairing, additional support material here. And actually, so if we build like a fin type thing here in the back, like vertical panel like that, we can have something that slides on that and then slides forward to cover that. But even then, just sliding pieces in general, you need like a C channel, right? You need something like that, and then something that's like, that goes like that, right? That goes like that on both sides, so that you can have a sliding motion be articulated there. But this prototype is looking pretty decent, actually. I'm quite excited to see this to become the way it is right now. So yeah, let's see. Straight, like a straight handle-ish geometry that goes all the way up here to the front, and then something that slides back and forth on that handle. That might be doable. Not really sure. So I've never done it before, so that's where tinkering comes into play. I don't know all the solutions, but it's part of the process, and you make some really cool stuff. Like, look at that. Any gear comes out. That's cool. Anyways. Alright, so I think I got a minute and a half left. So, yeah, next week I will be doing 2 streams that are going to be 3 hours long. So it's an hour longer than the stream that I'm doing this week. But that's to make up for lost time in the past 2 weeks. But today, or this weekend, I might do another one to cover for Christmas and New Year's, but I'm not sure yet. Again, I do give myself permission to skip those streams because it is holiday season. So just want to spend time with family and then continue off in the new year fresh and ready to go. But this is nearing completion. This is all we need to do now is figure out some sort of restraint mechanism, right, to keep this thing in place. But otherwise, it's looking quite nice. It works as designed. It pops out, and I don't know what else to say about it. It's looking real good. We just need something to hold it in place, and I'll probably figure that out tomorrow. I may or may not do a stream for that, but be on the lookout, I guess. So yeah, that's pretty much it for this stream. Thanks for watching. Stay safe, and if I don't stream tomorrow, I'll see you guys next week. All right, so take care.